Hey, what's up, guys? Today we're going to do a chapter 18 review. Look at some problems at the back of the book, back of the chapter there. Inferences about means. Uh, at any point in time uh, in this video, feel free to pause it. Try to answer the questions on your own, and then just click play. Do a little playback and see how your answers compare with our answers that I'm going to type up here, and go from there. I'm probably going to do just three. So let's go ahead and get started here. The first question I have is livestock are given a special feed supplement to see if it will promote weight gain. Researchers report that the 77 cows studied gained an average of 56 pounds, and that a 95% confidence interval for the mean weight gain this supplement produces has a margin of error of plus or minus 11 pounds. Some students wrote the following conclusions. Did anyone interpret incorrectly? Explain any misinterpretations. So here's our set of questions here. There's more than just what's on the screen. So right now you can pause and answer A, B, C. We'll go through them. And then there is a D and an E down here. So let's go ahead. You can pause. If not, I'm going to go ahead and get started. Question A. 95% of the cows gained between 45 and 67 pounds. Okay, now we're just looking at student answers, student conclusions. Okay, if there is a misinterpretation, you got to explain what it is. Well, this first one, kind of obvious. 95% of the cows gained between 45 and 67 pounds. That's not really correct. That was funny, but 95% is a confidence interval. So you would want to write, okay, the misinterpreted part was the confidence interval is for the population mean. Okay. The way this reads, it says 95% of the cows that were studied. The 95% is just a confidence interval, but this is more or less for the population mean, not the cows in the study. So that would be what I would write down for an explanation for that specific question. So we shall continue. Question B. I'll scroll up here. Like I said, at any point in time, once I see question D here, you can go ahead and pause the video and do that, or just let it play out. Question B says, we're 95% sure that a cow fed this supplement will gain between 45 and 67 pounds. Okay. So is there any interpretations that you would see in this problem? Well, first of all, look at this phrase right here, that a cow. Okay. What does a confidence interval apply to? Well, confidence intervals, make sure I can spell it right, are not for individual cows. Okay, we're looking at a population. Okay, confidence intervals, population. Okay, you're making an inference on the population mean. You got to keep that in mind. It's not just one individual cow. All right. So that's question B. Question C. We're 95% sure, this student wrote, we're 95% sure that the average weight gain among the cows in this study was between 45 and 65 pounds. What do you think? Well, look at this little phrase right here, that the average weight gain. Well, look back at your problem. What was the average weight gained? Okay, we know it's 56 pounds. Okay, so right here, you would write for C, in this study, we know that the average weight gain in this study, okay, was 56 pounds. Okay. Now, question D. I'm going to scroll up so you can see E. I need to fix something here. Question D. The average weight gain of cows fed this supplement will be between 45 and 67 pounds 95% of the time. Well, the average weight gain of cows does not vary. It's what we're trying to estimate. Okay? So, for this interpretation, we would want to say that the average weight gain of all cows does not vary. It's what we are, or we're trying to estimate. Alrighty. Okay, last part, question E. If this supplement is tested on another sample of cows, there's a 95% chance that their average weight gain will be between 45 and 67 pounds. Okay, well, this one clearly is misunderstanding what's going on. Thing about it is, that is not true. There's not a 95% chance for another sample to have an average weight gain between these two intervals, 45 and 67 pounds. There is a 95% chance that another sample will have its average weight gain within two standard errors of the true mean. Okay, I know that's a lot to type in for me right now. If you have to, you can stop, rewind, go back to that part. So that's question one. And what I'm going to do is I'm going to switch over real quick to Dosary, and we'll talk about question two. I'll see you in a second. All right, welcome back. We're going to look at problem 2 here. Due to time, we're just going to go over 2 of them. Number 2 says, hoping to lure more shoppers downtown, A city builds a new public parking garage in the central business district. The city plans to pay for the structure through parking fees. So I need to change that to garage real quick. That's killing me. During a 2-month period, which is 44 weekdays, daily fees collected averaged $126 with a standard deviation of $15. So questions A through E. Question A, we'll just read through the whole thing first, get an idea of what we're supposed to do. Question A says, what assumptions must you make in order to use these statistics for, I don't know why I wrote interference on there, for inference. Okay. Now you know why I don't teach English. Question B says, write a 90% confidence interval for the mean daily income this parking garage will generate. C, interpret this confidence interval in context. D, explain what 90% confidence means in this context. And then question E says, the consultant who advises the city on this project predicted that parking revenues would average $130 per day. Based on your confidence interval, do you think the consultant was correct? And why not? All right, so let's look at question A real quick. All right. What assumptions must we make in order to use these statistics for inference? Well, A, the data has to be independent. All right. It's got to be representative of all the days. Okay, what else? And most importantly, the distribution must be roughly close, whatever, normal without any outliers. Okay, that's what we got to assume. Okay. Now for part B, we're going to build our 90% confidence interval. So this, I'm going to go to the dictionary here. All right, so I'll pull this up real quick. Boom shakalaka. So we're going to go back to this confidence interval for the mean. X bar plus or minus Z star. I don't know why I call it Z star. The critical value. Our standard deviation divided by the square root of our sample size. So we got to be able to find these pieces of information and just plug and chug. So first of all, going back to what we need our mean, 126, average, mean, same thing. I don't know why people have that problem with that distinction. I can't find the mean. It's the average, it's the same thing. So 126 is the mean. I'm going to write all these values to the side. So 126. Our critical value. Well, let's go back to our problem here real quick. What confidence interval are we wanting to, for the mean, are we going to try to generate? 90%. Okay, two-tailed. Now 90%, the critical value is going to be 1.645, right? And now we are given our standard deviation, which was 15. Some people just write S. And our sample size was 44. Okay, how did I come up with 44? Well, that's how many days. During a 2-month period, 44 weekdays, daily fees collected averaged $126. So we're going to use this for our sample size. All right, so now we can do some math. All right. So let's plug in 126 plus or minus, 1.645 for my critical value. I'm such a neat handwriter. And then inside parentheses here, we got 15 divided by the square root of 22. I'm sorry, not 22, 44. Now, with a little work and effort, you can simplify this guy first. I would. So we got 126 plus or minus 1.645 times, this is going to be roughly 2.26. Okay. Now we can punch it in on our calculator, and just to save time, we get these two values. 122.28 to $122.28, and $129.72. So that is our confidence interval, 90%. All right. So I'm going to bring the question back up. So we've already done this part. We got our confidence interval. Now, the next part is just we came up with the numbers. Now you got to learn to interpret this confidence interval in context. So what you could write is we are 90% confident the mean daily income for the parking garage is between $122.28 and $129.72 based on this sample. Okay. So we're making an inference on the mean. We're going to be 90% confident, and we're basing it off just this sample. Okay, the more samples, the closer to normal we're going to get. Part D, explain what 90% confidence means in this context. Well, let me jump down here and scroll up a bit. Give me some room. What this means, guys, is 90% of all such samples will produce intervals that contain the true mean daily fee. So 90% of all such samples will produce intervals that contain the true mean daily fees. Now, question E. Hey, here we go. The consultant who advised the city on this project predicted that parking revenues would average $130 per day. Based on your confidence interval, do you think the consultant was correct? Well, this one's obvious, guys. Okay, we already know what our interval is. Is 130 in that interval? No, it's just right above it, actually. So what we want to write is no, the interval is below, money sign, there we go, $130. All right, guys. Like I said, feel free to go back, review, pause the video anytime while working on the questions yourself, and see how you do. Until next time, later on, Jack.